All right, let's talk about graphing lines or graphing linear equations. The first thing we want to realize when we're going to talk about graphing is, again, we already know how to plot points. So notice we have three ordered pairs on the screen here. But the question is, which of these ordered pairs do we want to use to actually graph this equation? And in order to get an idea of which points are actually on my or in my equation, we need to know which of the ordered pairs are solutions to the given equation. In order to figure that out, we're going to take our x coordinate. Remember, these are always written as x comma y. Right? And we're going to plug our x coordinate in for x. We're going to plug our y coordinate in for y. So notice in this middle point here, that means 6 times negative 4, right? Being our x, negative 3 times 3. And we're going to get negative 24 minus a 9. But negative 24 minus 9 is negative 33. Well, hey, that's not equal to the negative 3 that we had on the right side, right? So therefore, this point would not be a solution point, right? It wouldn't be a solution to my equation. It doesn't make it true. Now notice if we plug 2, 5 in though, we get 12 and 15. 12 minus 15 is negative 3. That is a solution. And the same thing goes for 0, 1. 6 times 0, 3 times 1, 0 minus 3 gives you negative 3 equals negative 3. That's a solution. Well, if those 2 points are solutions to my equation, then what I would want to do is plot them. Notice that negative 4, 3 wasn't a solution, but 0, 1 and 2, 5, and really all of the other solutions, right? There's many points out there, but all of the other places that would be answers or solutions to my equation will fall on that nice straight line that passes through our 2 good points, 0, 1 and 2, 5. And that's really the idea of graphing a linear equation. The solutions to an equation, right, a bunch of ordered pairs, make the equation true. The set of all of those points, the x, y coordinates, form the graph of the equation, or they form the line, right, for that equation. So a great idea, a great method would be make a table of values, make a table of solution points, plot enough points that we know the pattern. Minimum, you need 2, but again, I always recommend 3 or more. Then connect the points, right? Because again, that connection fills in that set of all of the other points. We don't have to find them all because once we draw the line, we know where they all are. A linear function, which is the type of functions we'll typically deal with, and are as an equation whose graph makes a nice straight line. The domain is typically all real numbers, unless for some reason we restrict that, such as in the real world where maybe negative numbers or something like that doesn't make sense. So let's take a look at a couple of examples very quickly here. So again, if we've got our equation up top, what we want to do is come up with a table of values. Now, you can kind of pick whatever numbers you want, but I'm going to notice up here that I have a little division going on. So if I'm going to divide by 2, I'd kind of like to use even numbers. So I'm going to usually start off, 0 is always a good idea, because very simply, 3 over 2 times 0 is just going to be 0. So then when I add that 2, now we've got a 2 on there, right? So we have the coordinate 0, 2, and I can plot that point. Now I'm going to imagine that I'm counting by ones here. So I'm going to label 5 and 5 there. So 0, 2 is going to be right up here on my axis, on the y-axis, right? Now I'm also going to plug in the point, actually 1, which might make for a little bit of a mess though. Notice 3 over 2 is negative 1.5. Times 1 is still negative 1.5 plus 2. Well, negative 1.5 plus 2, it's not that we can't graph that point. It's just that that one gets a little messy. 1, 1/2, right? 1.5 would be my coordinate there. It might be easier if I use a number like 2. Negative 3/2 times 2 is negative 3. Negative 3 plus that last 2, right? Because remember, we've got to use that plus 2 up there, is going to make negative 1. And notice I get the point at 2, negative 1, and I can plot that on my graph. Now notice all 3 of my points already make a nice straight line there, right? They're making a nice straight line. If we wanted to, we could plot a few other points. You know, I might go back here, maybe use negative 2, because 2 negative numbers multiplied will make a positive. And frankly, 3 over 2 times 2, the 2's cancel. I've just got 3 then, plus 2 equals 5. Again, you can always check those numbers on the calculator if that's going a little too quick. But negative 2, 5 would be a point that I can plot. And notice it seems to fall. Oops, that's not -2. -2, 5 seems to fall on that nice straight line again. And sometimes we might want to look for the pattern. Notice to get from that point to the next point, I went down 3 units and then right 2 units. Down 3, right 2 puts me right back on, right, 2, -1. And again, down 3, right 2 should make for another point on our line. Once we've got enough points plotted, we can just draw ourselves a nice straight line. Hopefully you're running through the points a little better than I did. I'm actually going to redraw that one real quick. I want to make sure I go from point to point. And notice the closer together those points are, the easier it is, right, to draw that nice straight line. Notice I put arrows on the ends. Again, we found about 4 points, but we know that all the points between those points would make our equation true. And we also know all the points beyond. So that's why we put those arrows on there. All those points beyond those points also make your equation true. Hopefully that helps you graphing equations. I'm going to stop the video now. I'm going to make a part 2 video though, where maybe we'll have a little bit more explanation of what do you do when your equation, right, over here, gets a little bit messier. So again, for now, just remember, plug in the points, right? Pick some x values, plug them into your equation, find those y values, right? You got your domain over here and your range over here. You can take those ordered pairs then, plot the points, connect the dots, and don't forget the arrows. If you have any questions, talk to your teacher. Otherwise, make sure you watch the second video where we're going to talk about graphing a few more examples and hopefully helping you out.